Welcome back. In this lecture we are going to understand about various thread pools used by Mule. I'll show you practically with an example. So we understood earlier that there are three thread pools basically, like CPU light, CPU intensive and blocking IO thread pools, which are used by the Mule runtime. And these thread pools are at the runtime level, not at the application level. And also we understood that HTTP component in Mule is using Grizzly behind the scenes, and there will be one shared Grizzly pool at the runtime level, not at the application level. Now let us see one sample flow and understand how thread switching will happen in this case. So this flow is having a HTTP listener as a source and logger, and this database component which is firing a select query, and transform message which is doing some transformation, and then inserting into database, set payload and logger. Okay. Now firstly, when the request comes, the Grizzly thread pool will actually receive the request, right? Whenever request comes, it will be delegated to Grizzly thread pool. So one of the thread from the Grizzly shared thread pool will handle that request. Then this HTTP listener is an observable and this logger is an observer, right? So this HTTP listener has to send the event to logger, but using which thread this has to be executed. Logger is doing CPU light operation. It is not a heavy CPU intensive operation, or it is not an IO operation. So the listener will invoke the logger using a thread from CPU light, or I can say the task will be executed using a thread from CPU light. Okay. Then after the logger is executed, logger again is an observable and this select component is an observer, right? Now the event has to be pushed to the select component using which thread pool. Actually database will do a IO intensive operation, right? So it's a blocking operation, right? So a thread from the blocking IO thread pool will be used to execute this select. Then again the select is an observable and transform message is an observer. So this has to push the event to transform message, but using which thread? This transform message actually is using heavy transformation logic, and it uses CPU intensively. This is doing some CPU intensive operation. So a thread from the CPU intensive thread pool will be used to invoke this transform message. And again, the transform message has to push the event to insert. Again, this insert is doing IO operation, right? So the insert should be executed using blocking IO. But then what about the set payload? It is actually neither doing IO, it is neither doing CPU intensive. Actually it is doing CPU light operation, right? We expect that this set payload has to be executed using a thread from the CPU light thread pool, but Mule uses some optimization. Too many thread switchings also are not good, right? So instead of executing set payload using CPU light thread, the blocking thread itself will execute. Why to actually switch the thread again? So Mule internally does some optimization, and the set payload will be executed by a CPU light, and then again logger also will be executed by the set payload also will be executed by blocking IO thread pool, and the same thread will be executing the logger as well. And now for this logger, the HTTP listener is an observer, right? This will be an observer to this observable. So now the event from logger has to be given to listener. Which thread will give? So same thread, same blocking thread only will dispatch the event to the listener, and that listener will send the response back. So this is how the thread switching happens in this case. Okay. So let us see it practically. I have the same application flow here, and to see the logs from all the components, what I have done is in my log4j2.xml, I have configured all the loggers to use the debug level logs, right? Everywhere I use debug so that I can see extensive logs. Okay, so one more thing here, actually, to just write some logs in transform message component. When I am actually iterating through each element after select component, I am actually writing a log. Log is a function, if you don't know. Log is a function in data view which will do a log as well as return some data, right? So just to show you some logs from transform message, I have done this. Otherwise, normally transform message will not do any logging. So now let me run it. Okay, it started. So let me clear the console first. I'll give a request to this HTTP listener. Here the HTTP listener is configured to listenet/test. Okay, so what I'll do is I'll go to Postman, and here I'm posting to /test, and here is some body just for testing purpose. Okay, so let me give a request in the console. Okay, let's lot of logs are there. I'll clear the logs for clarity and then give a fresh request. So you can see now on the console, I'll give a fresh request now. Okay, let's observe now. Here you are seeing a logger from the selector runner of listener, right? As I told you, HTTP listener will be using Grizzly thread pool, Grizzly, and Grizzly will be using a selector threads, as I told you in earlier video. So here you can see that this log is coming from a selector runner, which is actually logging the details about the request, right? And then after HTTP, what I have? Logger. Let us see the log from the logger. After HTTP, you can see that this is a thread name, CPU Lite thread, one of the thread from CPU Lite thread pool. Actually, so you can see that there's a log from CPU Lite thread pool, and here I'm using some data view configuration here, so these transformers are used, and here is a log. This log message is from which thread? CPU Lite thread, right? So CPU Lite thread is writing the log. Got a HTTP request. Then what? Select component. Select component is again blocking, right? You can see that there's a thread. See, this is a thread name. This is a thread name, which is a thread IO. CPU Lite and IO, blocking IO thread. The name here you can see. There's a log from the database component, and then transform message. It's doing CPU intensive. You can see these are all the logs from transform message component. See, in the transform message component I have logged this, right? These logs are coming from transform message component, and which thread is executing it? CPU intensive. Okay, then after transform message there is insert. Okay, now you can see here again this is a blocking thread. There's a name, right? So this is a blocking thread. These are the logs from database component, and this log, this is the insert query. You can see here this insert log is written by which thread? Blocking thread. Who is executing this insert? Blocking thread, one of the thread from the blocking thread pool. And then there is set payload and logger. You can see that rest all are executed by the same blocking thread. To minimize the thread context switches, actually the set payload and logger has to be executed by a CPU Lite thread. But to minimize the thread switches, the same thread will execute this one. Will execute rest of things. And see here you can see the response given back by the HTTP listener. This is a log from HTTP listener. So this log also is coming from blocking thread, right? So blocking thread has given the response back. So now you understood how this thread switching happens in a flow. In next video, we'll see actually how these thread pools will be used if I have a transactional flow. I'll show you various types of transactions also in my next video. See you there.